So for this question then, what I've done is just drawn a sketch of our suite. Initially, it has a diameter of 5 millimeters. And then we're told that after 4 minutes, its radius is now down to 3 millimeters. We're also told that the rate of decrease of the radius is inversely proportional to the square of the radius. And we're being asked to find an equation relating the radius to the time. And we must define the units that we use. Well, first of all, what I'm going to do is define the units. And by that, I'm going to let r be the radius in millimeters and let t be the time in minutes. So if we're to build an equation up, we start with this statement here. The rate of decrease of the radius is inversely proportional to the square of the radius. And I can write that as this differential equation. We've got dr by dt, that's the rate of change of the radius, okay, with respect to time. And it's going to be inversely proportional then to the square of the radius. So that means that we can call in a constant, which I'm going to call k, and being inversely proportional to the square of the radius, that's going to be divided by r squared. Now I could leave it as an equation like this, but I would prefer, because it's rate of decrease rather than increase, to put a negative sign here, because I would expect that to be a negative value, and that would mean that that constant k would be a value that is greater than 0. Now you could use this result, dr by dt, the rate of change of the radius with respect to time, is equal to k over r squared. But if you did this version, you would expect k to come out as a negative constant, okay? And you might want to try this version. This k here will be the negative of the k that I find in this solution. Okay, so it's up to you, but this is the version that I would prefer. Okay, so in order to solve this, we've got to separate the variables. By that, we need to put the r's on one side and the t's on the other. So if I rearrange this, I could multiply both sides by r squared, and I'm going to get r squared dr, and I'm going to remove the dt. It's as if I'm multiplying by both sides by dt, and that's going to give me the minus k and the dt. And I'm going to integrate both sides. So I integrate that side, and I could slip an integral out the front here, but this being a constant, it's better really to put the integral after the constant here. Okay, now if we integrate this left hand side with respect to r, just add 1 to the power, that's r to the power 3, and divide by the power. Okay, simple integration there. And if I integrate minus k with respect to t, I'm just going to get minus kt. So we get that is equal to minus kt. And I've got to add a constant. Now, it doesn't matter which side I add the constant to. I'm going to just add it on the right hand side, call it plus c. Okay? And I'm going to call that equation 1. We're going to come back to that equation in a few moments. Because what I've got to do next is work out what this constant is. And I can easily do that by looking at this initial condition. I know that at the start, the radius was 5 millimeters. So in other words, that's when t is equal to 0. When t is equal to 0, r is equal to 5. And what I can do now is just substitute those values into equation 1. So I'm just going to put up here sub in 1. All right, and if we do that, what we're going to get is r cubed. Well, that's going to be 5 cubed. That's going to be 125 then over 3. So we therefore got 125 over 3. Knowing that t equals 0, this term goes out, and that just leaves me with the constant c. Okay? Now I need to work out what k is. And I can easily do that now just by using this other condition. And that is that when t equals 4, we know that the radius r equals 3. And so if I, again, substitute these values back into equation 1, just put a note there, then what I get is that radius 3, when you cube it, that's going to be 3 cubed at 27. Divide by 3, that's going to give me 9. And that's going to equal minus t, which is 4 times the k. So minus 4k. And we've got the constant c, which we've just found out was 125 over 3. And so I can easily rearrange this. If I add 4k to both sides, I'm going to get 4k, and take 9 from both sides. 9 is 27 thirds, so 125 thirds minus 27 thirds. That's going to leave me with 98 thirds. And so therefore, if we just carry on down here, we're going to get that k, if we divide both sides by 4, k equals 49 over 6. And so all I've got to do now is just substitute this value of k back into 1. Okay. And if I do that, I'm going to get r cubed over 3 is equal to minus kt. We know that k is the 49 over 6, so it's minus 49 over 6 times t plus the constant c, which was 125 thirds. And there's an equation that relates the radius r to the time t. Okay?